Who doesn't like a little Michael Jackson to start off the new chapter? Radians and degree measures. It's a good thing you guys are not in the room because there are some very disturbing dance moves in the background. Thank you, Mr. Donofsky. All right, 4-1. What we need to do here on 4-1 is you're going to be your intro to trigonometry. So we're going to be describing some angles using radian measures, using degree measures, and converting between degrees and radian measures. And we're also going to use angles to model and solve real life problems. What a great time. All right, first thing what we need to do is we need to figure out what trigonometry means. Well, back in the olden days,
Christine Schaefer, we have something to sign in the office. Christine Schaefer, come on down.
It always messes me up. Trigonometry means measurement of triangles. So what you're going to be doing here basically from now until May, is finding different ways to measure triangles, different attributes about triangles, how to use triangles, here, there, and everywhere, and all kinds of fun stuff. So originally, trigonometry dealt with astronomy, navigation, surveying. Because of wonderful developments in calculus and physical sciences, trig expanded. And we're going to be able to use it in sound waves, light waves, planetary orbits, strings, pendulums, and orbits of atomic particles. Atomic particles. So, let's get into a little bit of vocab you need to know. A blank is determined by rotating a ray about its endpoint. That would be an angle. So make sure you fill this in. The starting position of the ray is called your vertex. Some of you may have heard of a vertex once or twice before. I lied. It's not a vertex. This is your initial side. Sorry, the starting point position of your ray is your initial side of your angle, whereas position after it's rotated is your terminal side. So that should make sense. Initial is always, where you begin with something. Terminal is where something stops. I'm the terminal side. Perception of an angle fits a coordinate system, coincides with the blank x-axis. That is the positive x-axis. So whenever you write an angle here, and we're discussing with the unit circle, your initial side always starts here with your positive x-axis. Okay, you always start from here. You're never going to start from up here on y. You're never going to start over here on the left or start down here on the bottom. You always start measuring from what I call 3 o'clock on a clock. Those of you who've seen clocks with hands, most of you probably have digital because you can't read them. This angle is in standard position. So, positive angles go around in a counterclockwise rotation. So you have to actually kind of go backwards. So you're going, positives go around this way and go on and go on and go on. If you go in the opposite direction, actual clockwise, that is called, or your negative angles. So that would be a clockwise rotation. Now, some things you're going to be running into is you're going to be running into some Greek letters, such as alpha. So here's an alpha, beta, and theta. Theta is a circle with a line going left to right. It is not the same thing as, that's no solution. Okay, that's also something else we call, if you go down like that, that's going to be the Greek letter phi, which we'll run into, oh my gosh, maybe second semester. So we won't worry about that anytime soon here. You can also label angles with uppercase letters A, B, and C. Now, if you look down here below, you're going to have a couple angles, A and B. So here's your A going around in the counterclockwise direction. So this is a positive angle. And then you have an angle going in the negative direction. That is angle B, or angle beta. These are called coterminal. The reason they are coterminal is they stop at the same point. So as you go around here for A, you stop right here, and then angle beta that goes and stops right here. These are not equivalent in degrees, but they are coterminal. That means they have a same end point. Same thing as if you have A going in the positive direction here, and beta goes positive direction, but it goes around and keeps going around. That's the same angle. That is coterminal. Okay. So there's a little bit of vocab. We got a little bit more here. Now we've talked about with your unit circle, learning unit circle, how you have to rotate stuff, and these are measured in radians. These are your pi values. So the measure of an angle is determined by the amount of rotation from the initial side to the terminal side. So it can go around your circle just by fractions, or it could go around your circle more than once, maybe twice, maybe 3 times. You know, if you think about a tire, how far a tire rotates around that circle in a mile, you can think about how many revolutions your tire goes around. Well, that's how many rotations it has also. So one way to measure these angles is in radians. Radians. To define a radian, what you're going to be able to do is you can use a central angle of a circle whose vertex is at the center of the circle, also known as the origin or origin. So this is your theta. Theta is how you measure radians or degrees. So if r is your radius, and then s is your arc length. And we're going to determine arc lengths here later as well. Alright, definition of radian. 1 radian, or you might abbreviate to rad, is the measure of a central angle theta that intercepts an arc s equal to the length of the radius r of the circle. So algebraically, theta equals s over r, where theta is measured in radians. And if you think about this, if your circumference of your circle is 2 pi r, well, if r is 1, that means your circle goes around in 2 pi. Well, 2 pi r, if you plug in 2 times 3.14 times 1, well, that is a 6.28 radians. 6.28 radians. So when you go around your circle, 1 radian, 2 radians, 3 radians, 4 radians. Notice you have 3, you're almost a pi, and we know pi is at 3.14, so 1, 2, 3, that's the 0.4 right there. We keep going 4 radians, 5 radians, 6 radians. This leftover, that's your 0.28 radians. So here's how you convert revolutions into radians. Well, half revolution is just taking half of 2 pi. So if you take 1/2 times the 2 pi, that gives you a pi radian. So you go around, halfway around is a pi. If you go 1/4 of a revolution, so that'd be up here, you take 1/4 times a 2 pi, that gives you a pi over 4. And then if you go 1/6 of a revolution, that's going to be right about here. And then that's going to be a 2 pi times 1/6, which is a pi over 3. That's how you get those pi over 3s, pi over 4s, 2 pi's over 3s, 11 pi's over 6s, all those, they all deal with the distance around your circle. Whew. Okay. So, finally, let's get to an example here. Now, we've kind of talked about this before, but 2 angles are coterminal when they have the same initial and terminal sides. So what we're going to do here is if you have 0 and 2 pi, they're coterminal because they have the same initial and terminal sides. As are the angles pi over 6 and 13 pi over 6. So pi over 6 is just like right here. This is pi over 6. But if you go around your circle one more time, so if you add, basically if you go around your circle, you're adding a 2 pi is what you're doing. And if you add a 2 pi, well, pi over 6 plus 2 pi, well, that's over 1, so you need to make that over 6. So that's going to be a 12 over 6, and that's a 1. That gives you a 13 pi over 6. So 13 pi over 6 and a pi over 6 are coterminal. What you can do is to find a coterminal angle, you can either add or subtract pi values, or 2 pi. So if you have an angle, no matter which way it's facing, here's your angle. If you go around it either this way in the clockwise direction, that's adding 2 pi, or if you go clockwise direction, that goes, that's subtracting a 2 pi. Those are still coterminal because they're at the same spot. So, how about that beginning? I know you guys are just so excited with all this fun stuff here, but hopefully you get these directions and these this vocab down, because it's going to be very important as we go through the rest of this chapter in this section. So, take it away, Michael. I hope you enjoyed your intro, and we'll get to the examples next. I got example 1.